So we are here to talk about stuff that is not really discussed outside, especially about the future of AI and computer science. And we are here, we have a lot of questions on AI-assisted coding. And how do you envision the future of software engineering? And we'd like to start off with this picture, which is from Andy Jassy, who's the CEO of Amazon. You can take a look at the picture. So we can take a few seconds to look at this tweet. And
a few hours, yeah, okay, well.
Yeah, I'm curious to know, what do you feel about that?
Okay, so the future of software development, that's a great question, and that's something I would think about, particularly within the College of Computing. I mean, I've done some programming. I like to use GitHub Copilot. It is a pretty amazing thing. It certainly speeds up a lot. Now, I'm kind of a recreational programmer. It's not what I do for a living. But it definitely, it's amazing when you need a routine or try to figure something out or you forget what the name of a command is, to just kind of put a comment in and boom, it starts writing the code for you. And sometimes you'll just start writing a function or write the code for you, and often it gets us right. The impression I get from what I read is that it adds about an average of 60%. I think this is probably, overkill. But it adds about 60% for average tasks for a programmer. So it's making programmers 60% more efficient. And it's oddly enough, it's not even. So it makes, let's say, a great programmer maybe 10% better. It takes an average programmer and maybe makes them 100% better. So it's almost like an evening. It helps. It actually kind of evens the playing field. A great programmer already knows all these tricks. The AI is not going to help that much. Where someone who's trying to figure things out, the AI is out there to help it. So we're already seeing a softening. Some of you might be on the job market, and you might have noticed that it's not as easy necessarily to get a job, particularly in software development, as it was 2 years ago. I read an article just last week in Wall Street Journal. It said there's a 6% unemployment rate in IT, which is actually higher than the average unemployment rate. I think AI is part of that, or at least people's concerns about AI is part of that. I think there's also a lot of overhiring. A couple years ago, so a lot of layoffs in the big tech firms, and I think that's also, so it's hard to know what the exact reason is, but already we're starting to see a change in the software development, and I think a lot of people are thinking, how is AI going to play a role? And there are some tasks. I think this is like what Andy Jassy is saying here, is like where you just need to translate or transform a whole bunch of code from maybe one language to another, or something that's very repetitive, and AI is just tremendous at that. So there's some tasks where AI is just going to automate everything. There are going to be a lot of tasks where AI is not going to help at all because you're doing something completely different and something that's never been seen before and complicated for the AI to pick. Maybe it's a sort of new algorithm that the AI is not going to figure out. I think in most cases it's going to be something where how you work with the AI is how you become more productive. So I think what you need to do is when you program, when you try to do things, figure out how to use AI, how to be able to know how it can play into how you can how to do the right prompts, how to make it your friend, how to not trust it. You should never trust it. You should look at the code, make sure it works, test it, all that stuff. And also, don't rely completely on it. Now, if you teach yourself how to program, like if you're using leak code, as soon as you type in a name, if you got GitHub Copilot on, as soon as you type the name routine, it's all done. So turn it off occasionally, just so that you learn how to code. But I find that I can do a lot more with generative AI because I know how to code. Because, like, if I want to manipulate data, I have a bunch of Excel files and I want to manipulate them, I can type in it to say ChatGPT, give me the pandas code for this. But it helps me to know because it's going to make a few mistakes. I can fix it up and then I can do very powerful things. But I'm able to do that because I know how to program, where someone who's never done any programming can't do that. So I think that still knowing how to program, knowing the principles of programming is going to let you go far. But you need to know how to use AI as, as a co-pilot, as they say, as an assistant. And but if I were to give advice to an incoming student, I would say maybe software development is not the place to be right now. Focus maybe more on machine learning. You're all in a machine learning club, or at least this is what this meeting is. Focus on the things that are much more data-centric: machine learning, data science, AI, cybersecurity. I think the things are going to be bigger on the computing side in the future.
Awesome. We're starting off with the spicy takes already.
Yeah, sorry.
That's awesome. And that's probably the most nuanced answer I've heard about the future of AI, how it's going to impact the job market. And the keyword is turn it off. Turn off GitHub Copilot, turn off Perplexity, and all.
Turn it off when you're learning, but use it when you're actually programming.
Yeah. So my next question is also on the same theme. So how many of you all have used Cursor, cursor.com? It's an AI-powered IDE. Okay, but you all should check it out. So Cursor lets you write apps with just English. You don't have to write a single line of code. I myself made 2 apps without writing a single line of code. It was all English. And recently, OpenAI launched their newest model, which is OpenAI GPT-01, which is really cool.
Lousy name.
Yeah.
But I'll tell you what scared me last week.
Yeah.
I took, so my background is theoretical computer science, a lot on the P versus NP problem, for those who know what it is. I took one of my exams from an intro theory class I taught a couple years ago, and it basically aced it. I mean, it didn't get everything right, but it did a lot better than, it would have gotten an A in the class. And that just freaked me out because I designed these to not be Googleable. So, I was just kind of like, how are we going to test anyone anymore?
Yeah.
So yeah, I was impressed.
Yeah, that's something I've seen as well. So when we get these online assessments, most of it can be solved using these AI tools. But yeah, I'm completely with you on how are we going to test people on these skills. So yeah, with all of these advancements, and I also happened to read one of your articles that you had posted, where you start off with this amazing line from the Oppenheimer, where Niels Bohr asks, it's the most important thing about algebra is not can you read the music, it's about can you hear it. And that's a nice thing. And you've said something similar, where you said that to me a program isn't static code, it's the embodiment of a living creature that follows my instructions to hopefully successful conclusion. Now, with AI and all of these things, do you still think programmers will be writing code line by line, writing functions line by line, or should developers find joy in the whole prompt wordsmithing process? I don't like to call it prompt engineering. It's very little engineering to it, but it's mostly prompt wordsmithing. Curious to know your thoughts on that.
I mean, programming was never, being a good programmer isn't really about writing code. I mean, that's part of it. But that's like saying a novelist is about writing words. And that's not it, right? It's this creative process. I mean, at least I view programming as you want to figure out you got this task, you want to figure out how to do the task. And there's a lot of tasks out there which, knowledge is already there and the machine learning can maybe just do it for you, and that's great. There are a lot of tasks out there that no one's tried to do before. And there, the programming mindset, the way to think about computing is going to come into play. And that's, so you can describe, the AI, I'd love to get to probably get to this point soon. We kind of just give pseudocode or an English description of the algorithm, and then the computer can create the algorithm. But you still need to do that kind of initial part. You need to figure out, what do you really want the computer to do, and maybe a few steps for it to do before it can give you the code. So, So I wouldn't think of, so yeah, so I mean, I think this, coding, like in the same way we used to do math, multiplication by hand, that's probably not going to do a lot of line-by-line code in your real jobs in the future. But I think understanding how to code, understanding how to think about computing is still going to give you a huge leg up when it comes to how you get computers to do what you want it to do in the future.
Yeah, that's something we talk about a lot, my friends, especially like writing pseudocode. That's something you can do and then give it to the AI. And then the AI can actually generate the code that is actually going to be compiled. So thanks for that. And my next question is, you've seen like major shifts in technology like the internet, cloud computing, mobile, and then now AI. So naturally, many comparisons are drawn between AI and the previous technological shifts. I'm curious to know, how do you think AI differs from all of these things?
So to me, it differs in, because I've seen a lot of shifts, and I would even go back to personal computers.
Oh, wow.
Which happened when I was, I got my first one when I was a teenager. Nice. So yeah, I've seen a lot of technological shifts, and they've all done dramatic things. I think the big difference with AI in general is that we're seeing a fundamental shift in the way we think about computing. So typically when we wanted to solve a problem in computing, we would think of, you take a problem, say you wanted to, give a great example, say you wanted to, you have a lot of junk in space and you want to plot the items in space and make sure there's no collisions or know where the collisions might be. So you might, in the old days, you would have to figure out all the positions, you'd have to work out the physics, you'd have some complex interactions with gravity and make it very complicated. You'd have to probably learn a lot of finite element analysis, partial differential equations, a lot of very deep math to try to figure out how you're going to track all these items to get around. But I was talking to actually one of our alums who actually works at SpaceX and was doing this, and that's not what they do at all. They do a lot of simulations, and then they feed it into a machine learning algorithm, and those predictions are extremely good. And you're starting to see this, this move away from sort of using logic as the first way to tackle a complicated problem to a very data-oriented way of tackling complex problems. So I'm not even talking about large language models and all this. I'm really just talking to this movement where we're now moved from a logic-focused computing to a data-focused computing. I mean, logic will always be there, but it's no longer, when I see a complicated problem to solve, no longer are we saying, say you want to play, it came up with playing chess or Go or playing, I mean, the greatest example to me is protein folding, where people are trying to use a logical approach to protein folding, got a little bit of the idea is to take you have a protein described by a bunch of amino acids, and you want to predict the shape it's going to create. And people have tried all sorts of algorithms and made small progress. And then DeepMind, Google's organization, applied the ideas from their work creating Go programs and chess programs, and just a lot of data, a lot of machine learning, a lot of simulations, and now they're able to predict them as well as you can, with the same errors you would get by actually creating the proteins and watching them fold. And they've now mapped out the shapes of like most of the known proteins out there. So so this whole different approach, this whole very data-oriented approach to try to understand difficult problems, it's become very powerful, and it's this transformation that I haven't seen this different way of thinking about computing. And the other things are really big enablers. I mean, certainly the internet, the cloud, the personal company, all these things really enabled us to do the mobile phone, right? All these things really enabled us to do things that weren't possible before. But this is different. To me, this is a complete change in the way we think about computing. So I think that this is, and we're still in the early stages. So where this is going, I mean, it's hard for me to predict, but where it's going is going to be really interesting to watch.
Yeah, I like the idea of we went from a logic-focused thing to a data-focused thing. That seems to be really cool. And yeah, thanks for sharing your take on that. So my next question is, you've seen a lot of students, you've trained a lot of students. I'm curious to know what traits differentiate the top 1% students from the rest of them. And I'm asking this from a place of self-improvisation so that we can learn from those students. What traits differentiate the top 1%?
The top 1%. You know, and everyone in Illinois Tech, by the way, is in the top 1%. So you're great students here. What makes me? I mean, you know, to me, it's not any one factor. So I think that, you know, the ability, at least in computer science, the ability to think abstractly, the ability to, I still think you need to think a little bit logically, even if we're moving to this data world. But to me, what differentiates, so you have to be able to do some level of problem solving, some sort of innate intelligence that goes there. But what to me really makes the best students are the ones who really let it encompass themselves, the ones who want to really learn, the ones who ask why, not just how. Like why can I do this thing? And it's also ones that are, you know, committed. So, you know, there's the story of the ham and cheese omelet. You know, so the cow is involved, but the pig is committed. In the sense that it's really like in that. So it's this commitment. It's this commitment to really wanting to know about computing, wanting to know about, you know, programming or whatever aspect of computing, or this actually I think true for any field. It's got to be, you've got to be excited. It's got to be something that takes you over when you're in the shower, when you're exercising, whatever you're doing. It's sort of like ideas might come to you because you're constantly thinking about it. When I started off as kind of a hacker, you know, when I was, I wrote like some computer games when I was in my late teens, early 20s. And, I'd wake up in the middle of the night and I would say, wait, I know how to fix this bug.
Eureka.
And then, you know, maybe it worked, maybe it didn't. But it was just always that in your head, right? And then, you know, as I became more of a mathematician and I would come up with maybe a proof in the shower or something like that, it's that part. That very top student is the one who gets very excited about what they do and really wants to understand it and is challenged and feels the challenge and the excitement about it. So that's to me what really differentiates sort of the very top students from, you know, the ones who are still really good.
All right, thanks. I think those are a lot of lessons for us. And yeah, thank you so much for that. And my next question is about LLMs. So I think most of us, it's safe to say that most of us use LLMs to kind of learn about new things and all of that. So do you think the education industry needs to undergo a makeover with the advent of LLMs? Do you think we need to have different, do you think assignments need to go away and we should be replaced with something else?
You know, it's a great question. And I think, you know, we and every other institution, high school, colleges are thinking about this. Okay, let me do a poll and I'm not going to take names. How many of you used an LLM to do your homework assignment when you weren't supposed to? Okay. And how many of you worked hard on a homework assignment, but your friends used LLMs and you felt like a chump? Yeah. So, yeah. So I think that's part of the that's part of the issue here. It's just too easy, as I said before. You know, it's virtually almost impossible to come up with a homework problem now that you can't feed to an AI machine. Now, this isn't a few years ago it was Chegg, so it's not like this is a very completely new issue, but the ability it becomes very hard, especially on these homework assignments. It becomes very hard to be able to do things where you can really properly assess the students. So I think the best way I could come up with it is let the students use AI or whatever system they are. I mean, I kind of like to say, use AI, use your friends, use a book, use the internet, use whatever you want. Just cite the material that you're using and write up the solution on your own. Although even then, not that many students actually follow those rules. So I think that the students who really want to learn will focus on doing these assignments. The students who are here just to get a degree might just use LLMs and just try to do the least amount possible to get through class. And I think we just have to acknowledge it. I mean, I'm almost thinking maybe we shouldn't even bother grading anymore.
That'll be cool.
I mean,
I'm all up for it.
Yeah, I think that's, well, it's not because I want to make your life easier. It's that maybe that's the wrong focus. Grade inflation anyway, grading means a lot less than it used to. And if we can take away maybe those issues of, focusing on, I mean, even the companies out there care less about the degrees. I mean, they're not even going to look when they hire you really at your GPA or your transcript. I mean, they probably won't look at your transcript at all. But what they want to know is, what do you know? They care a lot more about competencies these days than on degrees. I mean, it used to be a lot more on degrees. They figure, oh, you got a degree from the school, you must be smart. But no, it doesn't seem to be that way. They want, they'll give you these battery of tests. A lot of these companies will ask you a lot of tough questions. So they want to know that or they'll look at your GitHub profile. I mean, if you want to get a job, I think, build up a good GitHub profile so they can see what you've done. They really want to see that you're able to do what you can do. And so you can make it easy through college, through Illinois Tech, or pretty much anywhere else. But if you take the easy way out, you're just not going to learn. You're not going to be able to build up those tools and ideas that will help you get a good job and eventually get a great career. So I hate to put the onus on the students, but on you, but I think it's our job as professors is to give you that opportunity, is to be able to provide that knowledge to you. But what you do with it, how you take it in from us, how you implement it, how you do the assignments, that's a lot on you. And I really recommend, like I said, when you're learning, turn off the machines, try to do the assignments yourself. I think it's good if you need, to use the LLMs, maybe to ask a question about a definitional question. Something you might ask a TA, ask an LLM, that's fine. But eventually, do the problem yourself. At least write up the solution yourself. Try to really understand what you're doing, because that's what's going to really help you throughout life.
Awesome. It's very reassuring when a dean says that we are going to do away with grading.
No, wait. I didn't say that. It's like an idea I have. I don't have the magic wand you might think I have as a dean. I don't think grading is going to go away anytime soon. But I just don't think it's going to be as it shouldn't be your main concern. I mean, as long as you're getting good enough grades to graduate. But your main concern should be about learning, not just learning, but also the other skills, sort of like you're at a university. How do you work together as a team? How do you communicate properly? But also a lot about, obviously, gaining the knowledge and gaining the skills you need to succeed.
Awesome. So, I saw your tweet where you said you worked at Jan LeCun's office at...
That was a joke.
That was a joke? Oh, damn.
So the joke was, I was at NEC Research, and I worked in Princeton, and I worked under Jan LeCun. He was on the 4th floor, and I was on the 2nd. But so I know Jan, because I knew him from the time. I didn't really work with him. We were in different groups. It was just a joke. It was kind of based on a joke in a novel I read. So I'm sorry you took it seriously. But I do know, Jan is... it was sort of weird. Like back then, this was like around 2000. He was using neural nets. They had done some basic things involving recognizing numbers. They're using it for zip codes. They're using it for banks to deposit money, deposit checks. But it hadn't had this growth. I mean, it was just like very limited, and no one really in the AI world was taking him seriously. And now look, right? Now he won a Turing Award, which is the biggest prize in computer science, and it wasn't him, but one of his co-author, one of the other winners, who got up there and said, you know, we've always had this battle between the symbolic AI people, the logic people, and us, and we won. It was really funny. So.
Awesome. So I'm curious to know what has been your tryst with AI. When did you see something called as AI today? When did you see it first?
When did I see AI first?
Yeah.
Oh, that's a hard question. You know, the neat thing about AI is where you're using it the most is where you least realize it. So you're probably too young, but there was a time when it looked like email was going to die because just everything was a spam, and they had all these spam filters, but they didn't work very well, and it felt like email was just going to go away because of all this spam. And then all of a sudden, you know, people started applying. This is even before you know, the transformers and all the big changes in neural nets. And now all of a sudden, spam. I mean, it's not like it's a non-issue, but it's basically solved problem. I mean, it's no longer. Spam is, I mean, email is no longer an issue. Spam checkers are extremely good. Language translation, I mean, it's sort of like you can see the evolution. I mean, I don't know where I used AI first. Probably used it in a way like at least the machine learning model where you're learning from data. I mean, you probably used it when you wrote a letter. You used to mail things back in the old days. And you'd have a zip code. And even in the 90s, they were using automated systems to take the zip code that you wrote and add a barcode. It's almost like I knew someone who worked at the post office. He said, do you notice how there's a barcode on the mail you sent? And so that was using very rudimentary neural nets. So that was probably the first time it was, I didn't even know or realize it at the time. That was probably the first time it was being used. I think the big change, the big advances we started seeing really happened around 2012. Where people realized that neural nets could, with the advances in computing, they become a lot more powerful. They did far better on vision, recognizing objects than the other models for vision recognition. And then there was off to the races. And then the other big change was in 2016 or 2017. There was this paper from Google, Attention is All You Need, that developed the transformers model. And that was the thing that really, just to give you a little background, one of the problem in large language models, like say doing language translation, is that order matters. And it matters what order the words are in. French has a different order of words than English. You can't just translate word from word. So the initial models of neural nets had no way to do memory, so they were work fine for vision, but doesn't work so well for understanding long lists of words. And then, so people created these LSTMs, but those were very limited in how far they could look back. And then the idea of these transformers is you can kind of give a timestamp, encoded in a special way, into the data itself, so that, and then the machine actually learns where to look for different timestamps. And that's a very simplified point of view. The paper's pretty readable if you're interested in reading the paper. But that model really allowed the growth of, say, large language models. It really came out from variations on the transformer, and that's what really drove large language models. And then, obviously the big thing that happened at the end of November in 2022 is when OpenAI released ChatGPT to the world. And then that, the world changed.
Yeah, the world changed.
Yeah.
Yeah, it's nice to see that we went all the way from the 90s postbox machine learning to the Transformers paper.
Computing is I like to use, so people love to talk about moonshots, but think about the original moonshot. The original moonshot, 1961 or 2, JFK gets up there and says, we're going to get to the moon and back by the end of the century. At the end of the century, at the end of the 60s, we actually got to the moon and came back. It was pretty impressive. I was a little kid, 6 years old, watching it on TV. But you know what? 55 years later, we've gone no further. I know Elon's going to get us further, he claims, but at least for now, we've gone no further. The opposite is, in computing, there was never this moonshot. There was Moore's Law. Moore's Law said, Gordon Moore noticed that computing power was, doubling every
18 months.
18 months or roughly, right? But it became a mantra. It was sort of weird. It wasn't, it became a law, but also became a goal. So all the chip manufacturers aimed to improve computing by about, doubling every year and a half or so. And that just kept going. And when that just keeps going, computers just get more and more powerful over time. In around 2005, there was a change because the heat got too big, so the chips themselves. But that just led us to multi-core, many CPUs on a chip. It led us to specialized chips, GPUs, and now specialized machine learning chips. It led us to cloud computing, which opened up a whole new set of doors, and that created social networks. And then get enough power so that you can, you have your phone is now more powerful than a supercomputer from 20 years ago. It's just that, and that path is what keeps going. It's what, that plus, new advances in algorithms, new advances in storage, new advances, just all across, in networking. Just everything's been, you just keep getting better and better. There's no moon. You just keep going. And that's what I think has really powered computing and makes it such a powerful tool.
Nice. Okay. I like the way you said there's no moon. You just keep going.
You just keep going.
That's so cool. All right. So we are on time for the next section, which is the rapid fire section. So the first question is, you're going to settle this debate for a lot of people in the room. For coding.
What?
For coding,
yes.
For programming, which is the best operating system? Is it Windows or Mac OS?
I don't like to get into religious wars. I use Windows. I think if you're really a serious programmer, it's got to be Linux. So.
It's neither.
It's neither.
All right. So which phone do you use, Android or iOS?
No, I got a Google phone.
Okay.
Yes, I got the new Pixel Fold. It's awesome.
Awesome. Cool. And what's your most favorite app on your phone, apart from the usuals like Gmail and all of that?
My most favorite app?
Yeah.
Oh, that's a good question. I don't know if I have. It's mostly. Honestly, I don't think there's any games or anything I play, so it's probably some of the news apps. I'm boring that way.
Oh, okay. I was expecting Blackboard or Canvas, but
that would not be my favorite app.
Okay. So, favorite tech product you can't live without?
The favorite what?
Tech product that you can't live without.
That's probably the phone.
That's probably the phone. Okay. And favorite non-technical, non-software product that you can't live without?
Non-technical, non-software product I can't live without.
Yeah.
What technical? What technical? Oh God, I don't even know. Everything is. Is there anything you use today that's not technical? I guess a good pair of running shoes, maybe.
Oh, okay.
Okay.
Cool. Running shoes. And I know you covered this during the previous section, but from the top of your head, what are 3 traits of successful people? Can go. What are the 3 traits of successful people?
It's very simple. You have to be smart. You have to work hard. You have to take. Oh, I'm running out. Okay, that's maybe more than 3. You have to take risks, and you have to be lucky.
Wow.
And that's what and you can't control the luck. You can try to do your best to mitigate it, but those are the things I think you need to be successful.
Awesome. And what are some non-fiction books that you've gifted or recommended the most?
Well, obviously you got to read The Golden Ticket, PNNP, and A Search for the Impossible. That's mine.
I know.
What else is one of my favorite non-technical books? Technical books, you said?
Any non-fiction books.
Oh, non-fiction
any
books. So I love biographies.
Okay.
So, particularly Walter Isaacson, if you read his biography about Steve Jobs or Elon Musk, or I'm currently reading this one about CRISPR, Jennifer Doudna. And so I find that, just really reading about people who've been successful and trying to understand, usually there's some path where they're struggling and then something goes right and then they keep going. But but I think it's really interesting to get inside see people's lives and how they live their lives, and then you can see which aspects you think could be. I mean, you look at Steve Jobs, and there are things like, wow, I wish I could do that better, and there are aspects where I'd say, I'll never want to be like that. So I think, trying to pull some of those ideas into your own. Now, the single best business book I ever read is something called Critical Conversations. It's just a way, because it'll just happen to you in the future, that when you get into a meeting with someone, especially on a difficult topic, it's all about keeping the conversation safe. And I think if there's any one thing that's helped me most of being a dean, it's being able to have a civil conversation with, let's say some faculty who may be angry about something, or students, or things like that. But, I try to help as best I can, but the idea is try not to get it to be yelling. Try to keep the conversation. And always do it in person. Don't do it by text. Don't do it on the phone. Just if you have a difficult issue, email is not the way to deal with. It's fine for getting answers to questions, but it's not the way to deal with a difficult decision to make. Get the people in the room and get them talking and keep it comfortable.
Awesome. So that's Critical Conversations. That's the book.
Okay.
And my last question is, it's slightly controversial. Not as controversial as the first question, Windows or Mac OS,
Okay.
but are geniuses and successful people like you, are they born or made?
I don't think there's a. I think we all have our. It's a combination. I got lucky in a lot of ways. So, I think I was born with this innate desire to love computation. That's sort of weird. But, my life track took a certain way. I was lucky enough to go to a really strong high school, really strong undergrad. So I was lucky to happen to be at the same college as the person who invented my field, computational complexity, and take a class with him. So there's a lot of things that happened in my life that led me to where I am, and maybe a different path would have taken me somewhere else. Maybe I would have been more successful, maybe even less successful. I think it's just a combination of what your innate talents and interests are and where the life journey takes you. I think it's really just, there's no simple answer to that.
It's complicated.
And like I said, there's definitely a lot of, you should be willing to take risks in it, but there is a lot of randomness and luck that plays into it. Okay, do you want to see if there's any questions from the
Awesome.
audience?
Let's give a big hand for Dr. Lance Fortnow. So we have time for just about 2 questions. So since we don't have a mic, you all can stand up and say your question out loud. Any questions, you all can raise your hand if you have any questions.
No questions.
Yeah, Jacob.
I have a quick question to hopefully make it 3. It's I'll give you 4 options: Lovelace, Turing, von Neumann, or Babbage. Which of those 4 interests you the most, or is there a 5th, computational founder that really inspires you or intrigues you?
Well, to me, it's Turing.
Okay.
Especially his paper where he defines. He actually is the first one to give a formal definition of a computer in one of his papers, and that just happens to be the right definition. And so his way of thinking about computing, he was really the first person to really put that out there. Everyone else you mentioned, of course, are great people, but it's Turing that, and not the Turing that you see in the movies, Turing the mathematician, that really the way he thought about the field, the way he got us going, that's at least personally for me in the way I've done research. That's an incredible paper. I mean, all his papers are incredible, and he's an amazing guy.
Awesome. Yeah.
Hi. So, what are your thoughts on Gemini not able to, not able to set up alarms, but able to complete assignments and everything?
What do you mean?
Yeah, like
He's
Gemini
asking us.
can't handle simple tasks like setting up alarm.
I set an alarm with Gemini.
Yeah, but it can complete your assignment. What are your thoughts on it?
I mean, it's not saying alarms because it's not allowed. I mean, first of all, I use it to set alarms on my phone. You know, my fancy phone does it. But I mean, it's why doesn't it do my dishes? That's really the real question. Why do the tasks I don't want to spend time on? We'll get there. But there's some tasks that are really. I mean, even also just like when OpenAI came out with those chat models, it couldn't multiply numbers. You give it two large numbers, it gives you an answer that looks right, because it's very good at giving you fake answers that look right, but it didn't really solve it. And then finally they figured out, well, I'll use a calculator, or actually whatever, if you use ChatGPT now, it'll write a little Python program that multiply the numbers, which of course is how we multiply numbers. We don't multiply numbers in our head. We put it into a calculator.
Yep.
So I think it's just a way. There's some things it's good at. There's some things it's not good at. There's this book, Thinking Fast and Slow by Daniel Kahneman, about the kinds of problems that humans solve. The ones we think fast are the intuitive problems, that walking or driving, and the things that we think slow about are things which are like mathematical problems where you have to figure things out. And it used to be that the figuring things out were the things computers could do well, but now it's the other one. It's the intuitive stuff that these large language models seem to be good at. So, eventually, it's still in the early stages, so I think things will get more interesting later on. But that's I guess my synopsis of it.
Awesome. So we have time for just one more question. Yeah. You.
So I'm a data analyst. So I went to a boot camp. And,
Can you be louder, please, so that everyone
sorry.
can?
You can come in the front.
So I'm a data analyst.
Okay.
I went to a boot camp, and I've been observing with AI. I have one example. So the question is like, are things going to become a lot more customized to people? Meaning that like, I've been using Suno AI to create music.
Sure.
And I realized, like, in the last few months, I've been listening to that more than I have listening to, like, actual artists.
Oh, really?
I'm like, oh, wow, like, that's something. And now, like, what am I supposed to say when people ask me, like, what artists I listen to? Like, I just listen to music, I could say it. So do you think that's going to, like, follow, like, suit with other things?
Yeah, I mean, we're already, there's these recommender systems out there that are already kind of driving content towards learning what you like and driving content. But I do feel that we'll get to the point where AI is going to start making songs or movies or books or even physical items for an audience of one. When you order something on Amazon, there'll be AI will figure out exactly what you want, and then it won't build it until you order it. So it's like built to order. And I feel that, AI will learn a lot about you and learn about what you want and how you want it. And so we'll get to the point where AI will design products, entertainment, whatever, specifically designed for you. You'll get a newspaper that's written for you. Instead of like, Illinois Tech Today with all these different sections, you'll get a little thing that says, this is what, people try to do this now, it doesn't quite work yet. But we'll get there. It'll give you exactly what you want to know. And I think it's going to be really interesting that way.
Awesome. So Lance, if students want to reach out to you, what's the best way? Is it email, LinkedIn?
Yeah, the best way, LinkedIn, I always accept LinkedIn from students. not everyone else, but I always accept LinkedIn, and I'm getting a lot more now. So yeah, LinkedIn. I mean, certainly just send me email if you want to talk. lfortnow@iit.edu. Yeah, I love talking to students, and I hope to see you all. Future event, definitely graduation.
All right, let's give another hand for Log the Landscape. It was a pleasure having you. Thank you so much.